All right, so we were doing this quick exercise where we're going to say if this was dependent, independent, C was consistent, D was inconsistent, E was one solution, F was infinitely many solutions, G was no solutions, H was perpendicular, and I was parallel. Okay, so that's what we're trying to, all of these little characteristics we're going to evaluate for each one of these little pictures. So our first picture was obviously supposed to be two lines with the same slope, and they were drawn with this little guide mark to indicate that they had the same angles. Okay, so let's start at figuring out, is this dependent or independent? Dependent, what is the definition from your notes?
A system of equations that has an
infinite number of solutions.
Okay, so does this system of equations have any solutions? No. So it has no solutions. So we're going to go down here and put G. So G is one that goes here. What about independent? It has exactly one solution?
Yes.
Okay, so it's neither dependent nor independent. Is it consistent? What does consistent mean? What?
A solution of equations has at least one ordered pair that satisfies both equations.
Okay, so consistent means that there's at least one solution. Well, wait, what's independent mean?
Independent, a system of equations with exactly one solution.
And consistent means at least one solution. Okay, so independent is like a more zoomed in form of consistent. So independence is a type of consistency. All right. So this has no solution, so it can't be C. How about D? Inconsistent.
Yes.
yeah.
Yes.
Because it has
It has no solutions. Yeah, they can, and I'll show you where that can happen. That's when we get into quadratic equations. For linear functions, they're only going to have one solution, an infinite number of solutions, or none. All right. So, are these either parallel or perpendicular?
They're parallel.
They're parallel, so we put I in here as well. So that was number one, G, D, and I. Cool, so it's number two. Number two's picture, real quick, looks something like this. There was this circle, and then I had this little piece of a line right here, and dot, 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 dot. So some people might be tempted to think that, well, let's just go through it. So is this dependent or independent? You sure about that?
It's dependent.
You sure about that?
No.
Somebody do me a favor.
Yes.
Go up to the board for number two and point to where this system has a solution.
Right there.
The circle.
What does the circle indicate?
It's the circle is indicating where this line is
It's
going
gonna
across that line.
go right.
No, wait,
It's going to
wait.
skip that point.
Yeah.
Wait a minute. Wait, skipping.
Yeah, that's what open circle means.
It just hops over. Oh
It
God.
hops over it.
So
So the intersection point is not part of this system.
Oh snap.
So
Maybe snap.
can we just jump right down? It's inconsistent.
Just your back.
Yeah, it's inconsistent.
It's no.
It's D. Okay. How many solutions? No solutions.
Two.
So D and G tend to go together, right?
Yeah.
Yeah.
Now it's neither, you have no information to indicate that it's parallel or perpendicular, so D and G are all we know about this. Very good. Okay, so now on to the third, which isn't really a drawing. It's a system of equations, a real simple system. X equals 5 and Y equals 4. here what I kind of want you to do is draw a little graph. Doesn't have to be like a difficult graph or exact. So here's y and x is 5 and y is 4. So this is 5 and this is 4. And so if I write the equation y equals 4 as a line, that's what it is. It's a perfectly horizontal line. And if I write the equation x equals 5, I have a perfectly vertical line, right? Which forms a 90-degree angle at the intersection point right there. What are the coordinates of the intersection?
5, 4?
Correct. Who said that?
I did.
Good. Don't identify yourself by name because we're recording.
Oh.
Okay, but good job, person to whom I am currently pointing at. All right, or at whom. All right, so that's correct. Good job. So let's go through our list. Is this dependent or independent? Independent. Good job, person from Moldova. Okay, so it is B. Is it consistent or inconsistent? Consistent, so we get C. Okay, and does it have one solution, infinite, or none?
What solution?
E.
One.
Okay, is it parallel or perpendicular?
Perpendicular.
Perpendicular, so H. This was a fun one because we got all the letters. All right, so now on to number 4. Okay, number 4 is kind of like this. Okay, kind of like on number 2, this open circle business is causing some trouble.
So it's neither independent.
Does it have a solution?
No.
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 No solution.
So we're back to our
DG.
DG. DG.
Sunny D.
Those are my initials.
Okay, that's right. Well, okay, cool. Yeah, it's D and G. So it's inconsistent and it has no solutions. All right. The reason it had no solution is because this system never intersects anywhere. All right. So let's go on to number 5.
It intersected.
Yeah, number 5 is kind of okay, so number 5 is it dependent or independent? Independent. It has exactly one solution. Consistent or inconsistent?
Consistent.
So that would be C. One solution, infinite or none?
One.
Okay. And then parallel or perpendicular?
Perpendicular.
Good job. All right, so that is that. Now, the one thing we didn't see was what a dependent system looks like. Let's look at a dependent system. There was a dependent system in your homework assignment. All right, so let me show you that problem real quick here. So this was number 1 from the homework assignment. You were given 2 equations. You were given y equals 2x plus 2 and 2y equals 4x plus 4. And you were asked basically to do this exact same analysis here, only just a portion of it. So we have to compare these 2 equations and see what can we discern about them. Now just watch this. Before I can compare these equations, I need both of them in slope-intercept form. What do I do to this bottom equation to get it in slope-intercept form?
Divide by 2.
Divide by 2. So I'm going to divide both the left and the right side by 2. These cancel, and y equals to 4 over 2x plus 4 over 2. That reduces to y equals 2x plus 2, which if we were paying close attention should be a bell ringer since it matches our other equations. So these are identical equations, aren't they? So they're not parallel. I mean, they are parallel in a way. They are exactly the same. So if I were to plot this, on a little cheesy graph that I'm going to draw here. Okay, so x, y, whatever, 0. So here's my 2, right? So if I'm going to go up 2 over 2, so up, that's 2, up 2 over 1, up 2 over 1. So that's what this kind of looks like if you were to graph it in the calculator. And then if I were to graph the second one, I'm just graphing the same line. So if you watch this on your calculator, it will draw a blue line and then it'll trace over a red line. That's a dependent system because here's what it's asking me. How many solutions does this thing have? Well, an infinite number where these two lines share points. They share points at an infinite number of locations. Literally every single point they are sharing the same point. So that's why it's infinite. So this is a dependent system, which would be A, dependent, and F, infinite number of solutions. All right, that's how you do number 1. Now, I don't know. It'd be a good question. I don't know if these actually share the property of being parallel. Like, if I have two lines that have the exact same equation, if they are parallel, or if parallel means they have to have a different y-intercept. But in any case, we'll just leave that out for now. That's a dependent system with an infinite number of solutions. All right, so we'll just kind of go back to this. You guys did really well on this assignment. Good job.